In March, scientists delivered a final warning on the climate crisis. In the words of the UN Secretary-General Antonio Guterres, humanity is on thin ice, and that ice is melting fast. Urgent climate action is needed using all available technology, and space is one of the key tools. How do we make sense of data collected from space? How do we convince policymakers about the urgency of acting today? What is the role of international cooperation in all of this? During her visit to the United Nations in Vienna, Dr. Katherine, NASA Chief Scientist and Senior Climate Advisor, spoke to Martin Nesirky, Director of the UN Information Service, to give us her answers to these challenging questions. Stay with us to find out more, and happy Earth Day to everyone wherever you are in the world.
Dr. Katherine, welcome. You're NASA's Chief Scientist and Senior Climate Advisor to NASA Administrator Bill Nelson. I have to say this has to be one of the coolest jobs going, and I presume also one of the most challenging. What inspired you to work in this field in the first place?
Yeah, well, thank you. First of all, thank you so much for having me. It is one of the most exciting jobs I could ever imagine. My background, I was in math, computer science. I had a PhD in the School of Engineering, and I started doing research on climate when I was in grad school. I liked being outside, and climate offered the opportunity to bring my math and computer science and technical skills was something I really appreciated. I've also always admired NASA as an organization. I watch space movies in my free time. I remember a family vacation to the Kennedy Space Center when I was a child and getting to tour that. So I've always admired NASA. And so then when I got the opportunity to do partly climate while at NASA and learn about the rest of NASA science, I was really excited to join and to get to be a part of a really fantastic organization.
Well, we're very happy to have you here at the United Nations in Vienna. We like to think of the United Nations here in Vienna as the hub of space multilateralism, and of course it's home of the United Nations Office for Outer Space Affairs. Why do you think it's important for countries to get together here in Vienna to speak about space, and what do you personally get out of being here?
I think it's really important, at NASA, international collaboration and working with international partners is really important. We have international partners on many of our missions, whether they're Earth observing missions. So we work very closely with the German Space Agency on measuring changes in ice sheets. We work closely with other aspects of Europe, Japan, all on Earth observing satellites. And by working together, we can bring our technology together and go further. And we do this even outside of, beyond Earth observing. So we've been working on Artemis, our return to the moon, and the Artemis Accords includes many countries, and engaging internationally is really critical for advancing the study of science in general.
So maybe we can build on that a little bit. From your perspective, what's the role of the United Nations when it comes to climate action and space, and more generally the Sustainable Development Goals and space?
So one of the things I will be talking about this week is how we can use space for climate and sustainability. And I think a lot of what the UN is bringing together some of that, and we're talking about that while we're here. But space offers us the opportunity to see the entire Earth, and so we can provide information that helps people understand how the planet is changing. Space also provides the opportunity for technology and innovation. So as we're living and working in space, we develop technologies that can help us here on Earth with sustainability. And I will be talking about that this week.
There are many different parts of the United Nations working on space-related matters, and with NASA, including on climate action, the Food and Agriculture Organization, the World Meteorological Organization, the UN Environment Programme, just to name a few. So a lot of UN players. How do you rate international level policy coordination on climate action? Or put another way, what piece of the puzzle do you think is perhaps missing?
That's an interesting question. I mean, I think I approach climate as a scientist, and my job is to help understand how Earth is changing and how climate is changing and what we know about that and what information people might need in order to adapt to changes where they live or think about how the future might evolve. And I think my role as a scientist is providing that information to policymakers and decision makers like the UN and the different UN bodies so that they can use that for informed decisions.
In that regard, what do you see then as the most promising avenues and opportunities for example, climate action collaboration? For example, if we're talking about Earth observation or telecommunications, satellite navigation, what do you think are the most promising avenues at the moment?
I think there's a lot of promise. I think, as climate is changing and it's presenting more challenges in our communities, as we think about sustainable development, more ideas and inclusion and diversity of ideas, I think, is really important. And so bringing that all together to approach different aspects of the challenges we're seeing on Earth is really critical. And so I think there's a lot of promise about thinking about collaboration as a means of advancing innovation and advancing science.
A key approach at the United Nations and at NASA, obviously it's a science approach, and that is the emphasis on evidence-based decision-making. And we see the converse sometimes in the climate action field or in the field of climate change, where views are not necessarily based on science. How would you describe your approach at NASA on decision making, and why is it important?
I think what we view our role is bringing science to people so that they have the information that they need as they're making decisions and as they're facing challenges. And one thing that I think that NASA is really good at is recognizing everyone processes information in different ways. And so we use different means of getting information out there. We are very active on social media. Some people like to get information through that. And so we'll put little snippets of what we know about Earth and climate out on our social media accounts. We do press releases for more long form. We publish in scientific journals. We participate in some of these international scientific bodies that bring together all of what we know about climate, like the Intergovernmental Panel on Climate Change. We participate in those activities and try to get information that way. But we view our role as scientists is to bring information to people and recognizing that not everyone receives or processes information in the same way. So there's multiple forms of communication that are necessary.
Let's briefly come back to your own role at NASA as chief scientist, first of all. What findings would you like to highlight from your own research, both within and outside of NASA?
So prior to coming to NASA, I was a climate modeler. So I used mathematical models to understand how Earth is changing and how it might change in the future and how human activity interacts with that. So both how changes in energy and water and land might influence climate, but also how climate is influencing those activities. And that was a lot of my research before I came to NASA. Since I've been at NASA as chief scientist and senior climate advisor, I represent the research of others. I help bring and make connections within the agency, talk about what we're doing externally, work with other agencies to understand where there are areas of potential collaboration or partnership. And so I get to represent the science of others. And there's a lot of really fantastic science happening at NASA. So in my first year there, I got to be involved with both with Earth science. We put some new instruments in space to observe the Earth, and it was very exciting to hear from the scientists and learn about what they're trying to get out of those. But also beyond Earth, with Artemis, got to learn a lot about the science of going back to the moon. I was involved in some of getting to talk to scientists about the James Webb Space Telescope, so an astrophysics mission that'll let us look back in time and understand some of the early years of the universe. And it's been really exciting to learn about all of that science as well.
It is a really fascinating and exciting period in space exploration and technology. A lot of people, and you've worked in this field yourself on climate modeling, as you have described, a lot of people would like to see the role of space in helping to tackle climate change on Earth. We need to really mobilize everybody in this area. As a senior climate advisor, how do you get governments and politicians, policy makers to listen?
I think, again, our role is really about getting information out there and making sure they have access to it, and understanding how those challenges, the challenges they're facing in their communities and how space can help. So I often, when I talk to people, I think about where I am and what challenges they might be facing. So I would talk about how space can inform climate differently if I'm in an area that's prone to wildfire than I would in an area that's prone to sea level rise, because we have space-based capabilities that can inform both. So we have a very active disasters response team that can give us information about wildfires. We can see where fires are burning, burn scars and burn perimeters. We can look at emissions associated with fire. And that's really important to people that live in communities where there are fire. When I talk to people in coastal communities, I talk more about sea level rise, both what we can observe from space, as well as how we've combined that with models, both produced by NASA and other organizations, to think about how sea level might rise in the future. And we've developed portals to help those communities. And so I try to just relate to what's going on where people are and talk about what science we know, and what science we have on the horizon to help inform those decisions.
In communications work, this is very often the best way to break through, because you're able to put a human face onto the challenges that people are encountering where they live, whether it's on the coast or whether it's in the Amazon. I watched a really powerful film recently about an indigenous community living in the Amazon rainforest. At the beginning of the film, there are time-lapse photographs taken from space of one area, and it just shows the roads and then the fields encroaching into the rainforest. And it was really quite shocking and very striking to see. When you've got governments and politicians to listen, and the general public through your communications methods, whatever they may be, what's then on your to-do list for them?
So I think, depending on where you are and what challenges you're facing, everyone has different options. And so I think there's not a one size answer. And I like to talk about, what I do as I'm a scientist. I do research on that. We also, one thing that we have at NASA, we have a big active citizen science program. So for a lot of people around the world, how they can contribute and learn from. I also usually like to tell people about where they can get more information. So all of our satellite observations and data are publicly available, so people can look at what's happening where they are, and make the choices that are best for them.
This is really important, because for people to be able to understand the advantages, the benefits of space exploration and the technologies that have been used in space but are applicable on Earth, this is really significant, because there is also, if you like, a counter-narrative that in some quarters, that investing in space exploration, for example, going back to the moon, as you've mentioned, is a waste, and that we should be focusing on challenges here on Earth. So how would you convince a member of the public, perhaps a skeptical member of the public, that space is a game changer for modern society rather than a drain on the public purse?
There's a lot of reasons why we explore space, why we're going back to the moon. Some of them are related to science, so learning more about, with the moon, learning more about the formation of the Earth-Moon system. And just with respect to climate, we've learned a lot about what happens on Earth by studying other planets. So we learned about the ozone effect and greenhouse gas effect by studying Venus, and we can apply that to our understanding here on Earth. There's a lot we can learn both about other planetary bodies and things that we explore, as well as what we can learn about Earth from that. We also, as we go back back to the moon, we develop new technologies, or as we explore space, and those often have applications on Earth. So as we're exploring space, we bring everything with us, and so we think about sustainability, and we think about how can we reduce inputs. So there's a lot of research that's gone on the International Space Station that has applications here on Earth. There's water processing. We reprocess the water we use on the International Space Station, and that technology has been used on Earth in places where we don't have access to clean water. We grow crops on the International Space Station, and the research we've done into LED lighting and fertilizer also has applications on Earth. So on fertilizer, we've worked to work on a fertilizer that directs nutrients at plant roots at the rate that they need it, which on space means less inputs. On Earth, that means less runoff into rivers and lakes. We also, as we're thinking about that technology, as we get further from Earth, we have to, think about that even more. And so there we engage the public. So we have what's called a Deep Space Food Challenge, where we're thinking about how can you produce food with less inputs. And this is really important for us in long duration spaceflight, but it's also really important in large parts of the Earth where there are challenges in meeting food demand. And just one last thing for exploration, it's also inspiring. So we're inspiring the next generation of scientists and engineers that can help tackle challenges either on Earth or in space.
Well, you certainly sold it to me. That's a really comprehensive overview of precisely the reasons why we should be looking at space exploration and how to make the best use of the technologies. And you referred to, for example, food security and the need to be able to have sustainable ways to secure food while on a lengthy space mission, and the way that would be applicable on Earth, particularly in parts of the world where food security is really a big problem. Could you give us some other examples of how developing countries are benefiting from space technologies? The skeptical, again, individual might say that space is for wealthy countries and not for developing countries. So how would you counter that?
So all of the data that we produce is freely available to the public. This is a really important thing, is about open science and making sure that what we have is accessible. And while it's all open now and publicly available, we're also working to make it easier to use so people anywhere around the world will have an easier time of using it. And some of what we've been working on is moving data into the cloud so that you don't need a supercomputer at home in order to use it. We've also been working on translating. We have trainings on how to use Earth observing data, and we've been translating some of those into Spanish language so that they're accessible to non-native English speakers as well. And so we have activities going there. We also work with partners around the world in different countries. So we have a project that's joint with the USAID called Servir, where we work with local organizations on how they can use satellite information to face the challenges in their community. And so we work in Asia, Africa, and Latin America on those.
The UN, or the Office for Outer Space Affairs, has a similar approach in wanting to make space accessible for as many people and countries as possible. And I know that's a big part of the work that you at NASA do with the United Nations, notably through working with the United Nations. Some countries, such as Moldova, for example, have been able to launch small satellites for the first time. If we're looking again at NASA, what new initiatives or projects particularly excite you that are in the pipeline or already sitting there on the launch pad?
So we just launched in December. So we've launched in December. It's called SWOT, Surface Water and Ocean Topography. And this is going to give us a better understanding of surface water. So over land, that means we'll have the first global survey of water running through rivers and lakes. And water is really important for producing crops, for producing energy, and understanding how much we have is really important. Right now, we rely on stream gauges, which are great at measuring where they are. This will give us a global survey to show us where that is, and that's really important. It's also going to give us more information about the ocean, which plays a really important role in climate. Coming up, we're launching, and this spring we'll be launching a satellite called TEMPO, or Tropospheric Emissions Monitoring of Pollution, that'll be a geostationary satellite monitoring air pollution over North America. So that'll give us a better understanding of air quality. And while it's focused over North America, it's part of a constellation, and there are other similar capabilities already in existence in Asia and planned for launch to look at Europe. So we have a lot of exciting there. And then when I look beyond climate and earth science, we have some other exciting missions coming up. OSIRIS-REx will be bringing a sample back from an asteroid later this year. And we have a mission called Psyche that'll launch and go look at a metallic asteroid. So there's a lot of exciting science on the horizon at NASA.
So the space economy looks set to grow. The figures vary, but it looks set to grow quite dramatically. And if you look just at 2022, I think, if I'm not mistaken, there were 180 launches worldwide, and about half of them were commercial or launched by commercial enterprises. So how does the work of companies such as SpaceX or Blue Origin influence your work at NASA? And I guess more generally, how do you see the role of the private sector?
So we engage the commercial and private industry throughout our work, and how we engage and who we engage depends on what we're doing. So we rely on launch services from commercial companies. So when we're launching an Earth observing satellite, we'll often engage a commercial entity to develop that. Similarly, as we're going to the moon, we have a program called the Commercial Lunar Payload Services, where commercial companies will launch NASA robotic instruments onto the moon so that we can do science that way. And so we engage the commercial community through that. We also, in the science world, we buy data from commercial satellite companies. So we have a very active program where we buy data from some of the commercial Earth observing satellites to do science at NASA. And some of that science, we've counted trees in parts of the world. And so we can use what they're observing to advance the science we're doing. And so we work with these different organizations depending on what they are. We also have a very active tech transfer program. So we put out annually what we call spin-offs, which is an assessment of how NASA technology is now being used by the private industry or around the world.
A final thought. What does the science say about the adverse effects of space flights on the atmosphere and, for example, the growing number of launches, rocket launches? This, I'm assuming, is a question that is important also for NASA. So perhaps you could tell me a little bit about that.
Yeah, so throughout NASA, we're always looking to, minimize our environmental impact while advancing science. There are small effects along the launch trajectory, depending on the type of propellant. So it does depend on what the propellant is. The effects of rocket launch right now are small compared to all other human activities. It is something that we think about and look at. And again, we have an emphasis on, advancing science while thinking about how we do it at NASA.
Very last question. Would you personally like to be on one of these launches? Working for NASA, being the chief scientist, do you not sometimes wish that you would be donning a helmet and going into orbit yourself or into space?
I really enjoy talking to the astronauts and hearing about their experience. I enjoy learning about the NASA science and the science we do from space exploration. I am personally happy on Earth and like watching the launches and learning about them. But yes.
Dr. Katherine, thank you so much for being with us today.
Thank you so much for having me.
Thanks for listening. For more information about the work of the United Nations in and from space, visit the website of the UN Office for Outer Space Affairs.